All right, we are going to be working on Unit 1.3 and 1.4, solving multi-step equations using combining like terms and distribution. These do not have terms on both sides of the equation, so this will have the variable only on one side of the equation, and we're going to practice 1.3 is multi-step equations. 1.4 is multi-step equations but using fractions and learning how to clear fractions. So let's start over here on these notes. Today we're going to be distributing and combining like terms and clearing fractions to solve equations. We're doing this so that we can solve multi-step equations, all types of multi-step equations, and here's an example of something you will be able to solve by the end of this video. So let's start with the idea of combining like terms. Now I'm jumping a little bit. I've not gone over how to solve a two-step equation. It's my assumption that that's something that we're familiar with, and if not, you will see it repeatedly through this video and get comfortable with it, hopefully. So when we are combining like terms, I'm going to look at my equation, and I'm going to look on the left side and the right side of my equation. And on the left side, I'm going to look for anything that is a like term. That means it has the same exponent and the same power exponent. So in this case, I'm going to highlight in blue my like terms, which is 3x and 4x. So 3x and 4x are like terms. I can combine them. So I'm just counting up how many x's total. Well, 3x and 4x gives us 7x total. This minus 5 does not have any like terms that it can combine with. So I'm going to leave it as minus 5 and then equals, again, over on this side, there's nothing combining here, so we're just going to say equals 9. This is now a two-step equation. So you are going to see throughout the lesson today, we are simplifying our equations down to two-step equations. And then from here, we are going to solve, just as a quick refresh, we are getting x by itself. I'll highlight that in purple, which means we need to move the -5 and the 7. And we do that by doing the inverse operation, which is the opposite operation. So the inverse operation, and we can't just pick whichever one we want to do. We are going to get rid of whatever is adding or subtracting first before we take care of whatever is multiplying or dividing. So I always like to think if it's attached to the variable, we're going to leave it, and we're going to take care of the stuff that isn't attached first. So in this case, the inverse operation of -5 is +5. We do that to both sides. I will rewrite my equation, so 7x equals 9 plus 5, which is going to give us 14. And now we are going to do the inverse operation. 7 is multiplying with x, so we will divide. We divide 7 to both sides, and x equals 2. I'm not going to talk through how to solve the two-step equation in length like I did on that first example, but I did want to make sure that I covered it. So here's another example. Combining like terms means anything that's a like term on the same side of the equation we can put together. So here I have a +2a and a -5a. This negative is attached to the 5. It is a -5a. So my signs are different, which means I will subtract 5 minus 2 and get 3a, and then keep the sign of my larger number, which is negative. This -6, or this -6, doesn't have anybody to combine with, so I rewrite it, and I rewrite my 3. Now I'm going to solve my two-step equation. I get rid of whatever is adding or subtracting first. I'll do that in purple. I'm going to add 6 to both sides. That gets rid of my 6. I'll work from left to right, write my work down. -3a is still down here, equals 3 plus 6, which is 9. And then from here, I will do the inverse operation in blue, divide -3 to both sides, That cancels out to make 1a equals 9 divided by negative 3. Signs are different. When we're dividing, different signs give us a negative. So 9 divided by 3 is 3. And then the different signs give us our negative 3. So a equals negative 3. So that's combining like terms, solving equations combining like terms. Let's talk about solving equations with distributing. When we have distribution, our typical step here is going to be to multiply. Let's highlight in red here. We're going to multiply this negative 3 into our quantity 2p minus 5, which means we are distributing. So our negative 3 gets multiplied in with 2p minus 5. So I'll evaluate. Negative 3 times 2p gives us negative 6p. Signs are different. They're multiplying, gives us a negative. Negative 3 times 5 times negative 5 gives us positive 15. And then I'm rewriting my negative 60. I now have a two-step equation. I get rid of my 15 first by doing the inverse operation, which will leave us with negative 75 down there. These cancel, and negative 6p. From here, I can divide negative 6 to both sides. And this is going to give us p equals a negative, and a negative is going to give us a positive. And then can 75 be divided by 6 evenly? So we're thinking 75 divided by 6. If you had a calculator, you might punch it in. And what you might find is you're going to get 12.5. So that may be a way to write our answer. I'm going to write our answer as a reduced fraction. So if I get a decimal, that means this doesn't divide evenly. But I can reduce this by 3. And so when I reduce this by 3, I end up getting 25 over 2. So the point in this one is to show you that sometimes you will get fractions as answers. So it's not always going to be nice, neat, easy. Okay, you're not going to see this too often, but I wanted to include this in the notes. 4 is multiplying with this quantity here, is being multiplied by 4. So even though it's written in a different order, it's still multiplying into both of these. So I'm going to get 16 minus 20p equals negative 4. This is a two-step equation. I always move my term that's not attached to my variable first, in this case the 16, which will make negative 20 equals negative 20p. I'm going to, let's see, I'll use red. I don't know, I've got all kinds of crazy colors here. Let me divide. I'm going to divide by negative 20 to get rid of the negative 20 that's multiplying with p right here. If there's no sign in between, if it's just sitting next to the number, it's multiplying. So we divide to get rid of it. All right, and then in black here, these cancel to leave p by itself, or 1p, and negative 20 divided by negative 20 is positive 1, so p equals 1. So that's just kind of a brief introduction to combining like terms and distributing. Now we're going to create or solve some more complicated problems on these. So here are the steps. I'm always going to look to distribute first. After I've distributed, if necessary, then I will combine like terms, if I have like terms. Then I'm going to move variables to one side, constants to another. I don't know why that's consonants. Constants to another, if necessary. In this case, we're only working with variables on one side. And then that will give us a two-step equation to solve. So let's take a look here at A. My first step is to distribute. So I'm going to distribute if I can, and in this case I can. This 6 is multiplying here to give me negative 12a plus 30. This negative 12a is not being changed or affected by anything. It's just hanging there. So I'm just going to rewrite that negative 12a. Same with this negative 114. My next step is to combine any like terms. And those are like terms on the same side of the equal sign. So I can't combine 30 and 114 because they're on different sides of my equal sign. I cannot put this with this. But I can put negative 12a and negative 12a together. And when I combine them, the signs are the same. This is a negative and a negative, which means I will add them and keep the sign. Negative 24a plus 30. So let me do some highlighting here so you see where numbers came from. I took this purple and this purple. When I combined them, it made this one. And then negative 30, I'll highlight in blue, didn't have anything to combine with, so I just rewrote it down here. And then that equals negative 114. I've now created a two-step equation. So I will solve it by subtracting 30 to both sides first, which is going to give us negative 144. And then my negative 24a. To get rid of a negative 24 that's multiplying with a, I will divide. So that a equals a negative 144 and a negative 24. So it's going to give us a positive answer. And it is positive 6. Okay, so I followed my steps. I distribute, then I combine like terms on the same side of the equal sign. You can skip step 3, that's for the next lesson, and solve the two-step equation. So I'm not going to do all of these. I'm just going to do a couple more. Let's see. Let's take a look at this one here. So I have distribution. Negative 3 times negative 8 is a positive 24x. Negative 3 times a negative 8, or times a positive 8, is a negative 24. So I took that, multiplied it, got this. Took this, multiplied it, got this. Plus 24x equals negative 192. I'm going to put my like terms together here in blue, which is going to give me 48x minus 24, didn't have any like terms, equals negative 192. And now we can start moving our two-step equation to solve it. So I'm going to add 24 to both sides here, which is going to give us negative 168. You could calculate that. I'm less worried about the numbers at this point and more worried about the process. Divide 48 to both sides, and x equals, let's see, divided by 48 is 3.5, which is no good because we have a decimal. So again, sometimes our numbers don't work out well, and we can be conditioned to, oh, what? Yeah. Sorry, plus 24. I'm just double checking on the calculator to make sure I didn't do anything silly, because sometimes we make mistakes too. That's the other part of this. Negative 168 divided by 48. And I get negative 3.5. So I'm going to roll with that. If I did something goofy, then take this opportunity to see sometimes we don't do things perfectly. If that's the case, I would go ahead and just reduce these. maybe by, I don't know, I can guess and check. 168 divided by 12 is 14. So if I divide both these by 12, I get negative 14 over 48 divided by 12 is 4. And then I can still reduce that. Now that it's smaller, I can still reduce it by 2. And I get negative 7 over 2. Okay, kind of a pain, but I want you to see the process and how we work those out. All right, I'm going to skip those two. Clearing fractions. So up here, what we did here was 1.3. You distribute, combine like terms, solve the two-step equation. In 1.3, we're going to talk about how do we do that when there are fractions, or clear fractions. So the first thing I'm going to do is I'm going to identify the least common multiple of the denominators. That's the smallest number that's in common that they multiply into. Then I'm going to multiply every number or every term by that number. Then I will evaluate each. So I'll work it out either by reducing with canceling or multiplying and then dividing. Then I can distribute, combine like terms, solve the two-step equation. So let's take a look at A here. I have a fraction. I have 3 and 3, and this is technically sitting over 1. So my least common multiple is 3. So I'm going to multiply each term by 3. And every term has to be multiplied. So this is a property of equations that we're allowed to apply, but we can only apply it if there's an equal sign. If it's an expression, we can't do this. But if there's an equal sign, and we have to then do it to every term. So looking at this, I'm going to show you on the first one how to multiply and then divide. So this is technically 3 over 1. So in blue here, 3 times 4 is 12. And it's still sitting over this divided by 3, even though I wrote a 2 like a crazy person, over 3. And then if I reduce that, 12 divided by 3 is 4. So I get 4k. So I multiplied 3 times 4, got 12, and then divided by 3. You could do it that way. You can also just cross-cancel, which I think is probably easier, like reducing. 3 and 3 reduce, and I'm left with 4k. My second term, 3 times 2k is 6k. And on my last term, I'm gonna cancel. The 3's cancel out, so I'm left with negative 10. So we do all this clearing the fraction stuff because now we have a two-step equation that's easy. Not even two-step. Now I'm just going to follow. Distribute. Do I have anything to distribute? No. Combine like terms. I do have like terms. I can combine 4 and 6. That gives us 10k equals negative 10. And then now I solve two-step or one-step, depending on what we're left with. I can divide 10 to both sides so that k equals negative 1. All right, again, probably not going to go through all of these examples, but I'll show you. Like here's example B. And there's a lot of fractions going on. So I'm going to look at each one of these. I have 5, 5, 5, and 25. So 25 is the least common multiple. So I have to take every term, and I'm going to multiply by these, but I'm going to leave the signs since I'm multiplying. And 25 is my least common multiple. And then in blue, I'm going to show you what happens. So I'm going to reduce here. 5 and 25 reduces to 1 and 5. So this is now 5 times 3k, which makes 15k. For our next one, 5 and 25 reduces to 5, so I'm doing 5 times 4, which is 20. What this does is it gives us whole numbers to work with instead of fractions. Okay, again, 5 and 25 reduces here. And this is 5 times 8, but we have this negative sign. So remember, it's going to be minus now 40. And then equals, these 25s cancel each other out entirely, so it's just 19. So when we multiply across a fraction, across an equation with the least common multiple, it will give us all whole numbers. So now I have to combine like terms. There's nothing to distribute, so I'm combining like terms. So I have 15k doesn't have a like term, but 20 and negative 40 do. Becomes a negative 20. And then I'm adding 20 to both sides. So 15k equals 39. And then I'm dividing 15 to both sides so that k equals 39 over 15. That's my fraction. Doesn't reduce. Or actually it does reduce. 3 goes into both of those. So let's reduce these. This is my bad. I jumped the gun here. I got excited. Okay. I can divide both these by 3. That's 13 over 5. All right. I'm just going to show one more example here. I'm going to move this out of the way. Okay, so here's another one. I'm looking at my fractions. I could either distribute first and then take care of my fractions, or I can clear my fractions first. I prefer to clear them first. So this whole thing is one term. So I can multiply this whole thing by, my least common multiple of 8. 2 goes into 8, and 8 goes into 8. So these cancel out to give me 4. So 4 times 3 is 12. And then I have n plus 3. Equals, this side is also being multiplied by 8, because I have to multiply every term. Those cancel out, so it's just 69. And now I'm going to follow my rules. Distribute. (12n plus 36 equals 69). There's no like terms to combine, so I'm going to start my two-step equation. So that should give us 33. And then I divide 12 to both sides, and n equals 33 over 12. All right. So this is the last part of 1.4, clearing a number when it's dividing a quantity. So in this one, I have this whole quantity here of 7 plus n, and that whole thing's being divided by 8. So we can get rid of that divided by 8 by multiplying 8 to both sides. That makes those cancel out, so that 7 plus n equals negative 8. Now we have an equation that we can solve. I would subtract 7 to both sides, and n equals negative 15. So when you have like a whole group being divided, you can multiply that denominator to both sides to get it to cancel out, so that you're left with the numerator. 2 times 3 is 6. One-step equation. R equals 9. Hopefully you're feeling comfortable on this. What am I going to have to multiply to both sides on C? That's right. I'm going to multiply 5 to both sides on C. And then I can solve my two-step equation. So that's going to give me 8. So 2k equals 8. Divide 2. And k equals 4. All right, and I'll do this last one. Sometimes it's on the other side of the equal sign. That's fine. Move this out of the way. We're going to multiply 3 to both sides. 3 times 2 is 6. These 3's cancel. I have a two-step equation. I'm going to add 6 to both sides first, so that 12 equals 3x. And then I'm dividing 3 to find that 4 equals x, or x equals 4 as we like to write it. Okay, hopefully this was informative, and I hope I didn't blow through this too quickly, but I didn't want to waste too much time through it. So thank you for your time, and I hope if you have questions, please let us know.